Okay, so this is a tabular approach to determining the optimum price and the optimum quantity. We have looked at the equations based approach so far. In this question, what we are going to do is, in this specific scenario, we will first of all we'll see what is the optimum price, optimum level, and we'll try to find out at which level is the highest possible profit achievable. And then we'll back work to determine what is the optimum price and quantity. Now, this method, see, in real life, you might not be able to find the optimum price so easily because there are so many other variables at play in these situations. It's not just price and quantity which are correlated. There are a lot of other variables also which have an impact on determining the optimum price. But here, under laboratory conditions in our textbook, this is of course limited in terms of what we are capable of achieving and capable of demonstrating. These are laboratory conditions. Only two variables or three variables will be examined together. Okay, so first of all, let's write down the demand and the price per unit. Okay, once I write this down, what I should do is I should get my total revenue. Total revenue is quantity into price. If we want, we could label these columns. Column C equal to column A into column B. We'll get the total revenue in each of these cases. Now we have the number for total revenue. Okay. And when we have total revenue, we can always calculate the marginal revenue. How is marginal revenue calculated? Marginal revenue is revenue achieved by producing one more unit, by selling one more unit of the output. 50. Then 94 minus the previous one. Then revenue, total revenue at 3 minus total revenue at 2. Okay. Now let's see what does the cost, how does the cost part look like? Now the cost part is given here. This is the total cost. Okay. This is your total cost. I could call this column E, and we know that this is given to us. We don't have to calculate. This is given to us. Just have a look at the total cost data. Now, marginal cost is cost of producing one more unit of the output. Okay, marginal cost is cost of producing one more unit of the of that particular output. So let this be my column F. Now see the kind of relationship that you will come across. So this will be 44, 12, 15, 14, 10, 15, 12, 13. So what do we have here? We have the marginal cost. Okay. Now marginal cost data is available and we can now calculate the profit. Okay. Profit has got nothing to do with marginal cost. Let this be column G. How is profit calculated? C, that is total revenue, minus E, that is total cost. Okay. This is how you will calculate the profit. Total revenue minus total cost. Now tell me, when is profit the highest? If you observe carefully, profit is highest at 102, this row. This is where my profit is the highest. Now look at the marginal revenue in this case. The marginal revenue in this case is 14. What is the marginal cost? The marginal cost is 12. Now we had studied some time ago that marginal revenue and marginal cost. When marginal revenue is equal to marginal cost, at that time you have your profit maximizing level of output. You see, before MC, see, at 102, the gap between marginal revenue and marginal cost is the least. Okay. Now, just before that point, see here the difference is 2. Difference between marginal revenue and marginal cost is 2. One step before that, the difference between marginal revenue and marginal cost is 5. And one step after that, one price point after that, the difference is again more. So basically, the difference between marginal revenue and marginal cost keeps on changing, but it is least when the selling price is 32, the marginal revenue is 14, and the marginal demand is, sorry, and the marginal cost is 12. So, one step before the optimum profit was reached, the difference between MCMR was more, and even after that, the difference between MCMR was more. See, as per the marginal revenue, marginal cost wala equation, if we are if we can theorize the cost equation, if we can create the marginal revenue equation, if we solve it, there will be an optimum price and an optimum quantity. But because it is an equation, you might get 6.8 units or 7.4 units or something like that, which might not be, which is in practical life, it is not possible to have 6.4 units sold or 7.3 units sold. So that, see, if it's a mathematical equation, it will have a solution. Nobody is, going to deny that. But that is not practical. You cannot sell zero point 0.4 units. You cannot sell zero point 0.3 units. You can sell 6. You can sell 7. So at 7, it is my optimum point. Okay. So economic theory might tell you that MC is equal to MR, and it is absolutely true. There is nothing wrong with it. The only problem is that if you apply and solve an equation, you might get 0.3, 0.4, 0.5, 7.4, 7.6, something like that. And that will not yield any optimum answer. So when a table like this is given to us, you have to calculate the total cost, total revenue, marginal cost, marginal revenue. And here what we did was we arrived at the optimum approach. Sorry, we arrived at the optimum selling price and optimum quantity, which might not necessarily be, you know, a point where MC is equal to MR, but it will be a point where this optimum maximum possible profit or best possible profit is achieved. So the tabular approach is all about that. Cases where, marginal revenue equal to marginal cost equation yields a different quantity. Like for example, it yields a number which is, you know, 6.5, which is not the optimum answer. So in that case, the tabular approach is very, very helpful. In real life, we might find ourselves using the tabular approach the most. And see here, although not MC, although marginal revenue, marginal costs are not equal, at this particular level of demand and at this particular level of output, the profit is the highest. The difference between the two is the least. So although difference is not zero, the difference between the two is the least, and somehow it is a better version of profit as compared to any other price level. Better than 35, better than 29, better than 50, better than anything else. So although MC is not equal to MR, MC is very, very close to MR. So the tabular approach helps you to establish that particular part also.